In our study of quadratic equations so far, we've looked at how to solve by graphing, by factoring, and completing the square. Now, graphing is hard to do, it takes a long time, and is not very accurate. Factoring doesn't always work for all types of quadratic equations. And then completing the square takes a little bit of time. So our fourth and final method is the quadratic formula. So given the quadratic equation, we want to first write it in standard form, ax squared plus bx plus c equals 0, so we can identify what the a, the b, and the c are. So we're going to develop that formula in class. And so once we've done that, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now, one of the biggest mistakes I've seen is that students forget to draw this line underneath everything, so including the negative b. And so this is called our quadratic formula. So let's see how we use it. So in our first example here, we have 2x squared minus 5x plus 3 equals 0. And so the 2 is our a value. Our negative 5 is our b. And our positive 3 is our c. So we're going to plug these three numbers into the quadratic formula. So we have x is equal to negative b. And notice it's already negative 5. So negative 5 will give us positive 5. Plus or minus the square root. So we have negative 5 squared minus 4 times a, our a value is 2, times c, our c value is 3. And all of this is divided by 2 times 2. So let's first figure out what's in our square root. And so we have 25, and then minus 8 times 3. So 25 minus 24 is 1. So we have the square root of 1 inside the radical, all divided by 4. So this reduces or simplifies to 5 plus or minus 1 over 4. So let's just try to understand what this means. So we have the plus or minus. So what we can do is write it out. I'll separate them so you can see it. So we have 5 plus 1, all divided by 4. But we also have 5 minus 1, all divided by 4. Now, because all of these are integers, we're actually going to figure out what each of these values are. So 5 plus 1 gives us 6 over 4, which reduces to 3 over 2. And 5 minus 1 is 4 over 4, which reduces to 1. Okay. So let's try a different one. I'm going to leave this number 2 for you to try. And let's go on to number 3 here. So it's a little bit different. So number 3, again, so we don't have a number in the front. So when there isn't a number, remember the number is 1. So our a is 1, our b is negative 2, and our c is negative 4. So we have x is equal to, so again, it's negative 2, so it's going to be 2 plus or minus the square root, negative 2 squared, minus 4 times 1 times negative 4. Now, I kind of didn't draw my radical long enough, so I'm going to extend that. All of this is divided by 2 times 1. So that's fine. I don't need to draw the 1 because it's just 1. So I have 2 plus or minus, and inside my square root, I get 4, and then negative 4 times negative 4 is 16. So 4 plus 16 is going to be square root of 20. If you can't do this in your head, you can also use a calculator. Don't forget that when you square a negative, it's always going to be positive. Okay? And all of this is divided by 2. Now, in this case, we can simplify the radical. So the square root of 20 is actually the square root of 4. So I'm just going to show that up here. So the square root of 20 is the square root of 4 and the square root of 5. So you want to find a perfect number or a perfect square that goes into 20. In this case, it's 4. So the square root of 4 is actually going to be 2. So I can change the root 20 into 2 root 5, all divided by 2. Now what we want to do next is we can take a look to see if we can simplify any further. And when I look at this question, I notice that all of these terms, all separated by a plus or minus, they're all divisible by 2. So because they're all divisible by 2, I can divide each of these 3 factors by 2. So we have x is equal to 1 plus or minus root 5 when I divide all the numbers that I've circled in red by 2. And so our answer actually ends up being 1 plus or minus root 5. Now I don't have to separate this one like I did here with the 2 fractions because these actually ended up being rational numbers. So I actually found the numbers. But when the number is a radical, we don't have to separate them, and we can leave the plus or minus sign in the middle to show that we do have both of them. Okay, now another thing I want to take a look at in this video is the nature of the roots. So the nature of the roots, so remember that the roots are the solutions of the quadratic equation. So it is where y is 0 in the quadratic function. So remember, this is a function because it's y equals. And it's also represented by x-intercepts on the graph. So remember, roots are in the equation, zeros are referred to the function, and x-intercepts refer to the graph. Now, when I ask you what's the nature of the roots, you can determine the nature of the roots for a quadratic equation by the value of something called the discriminant. So I guess you can almost think of it as like discriminate. What kind of values are they? So this is the expression. So the discriminant is the b squared minus 4ac. So if you look, that is the expression that's underneath the radical sign in the quadratic formula. So let me rewrite this again. So remember, it's negative b plus or minus the square root of b squared minus 4 times ac, all divided by 2 times a. Now the reason that it's called the discriminant is because whatever b squared minus 4ac happens to be, that will determine how many solutions or how many roots or x-intercepts or zeros there are. So there are 3 possibilities. So the first one is that we can get 2 distinct roots, distinct real roots actually. So for example, when we draw a parabola, the graph will cross the x-axis 2 times. So why does this happen? So the value of the discriminant, that means when I go negative b plus or minus, I actually have to be adding a number. So b squared minus 4ac, must be positive. So that means that b squared minus 4ac is greater than 0. Because it's greater than 0, that means I'm actually going to have a number to add and also have a number to subtract, giving me the 2 solutions. So let's take a look at the example. So this is my a value, my 7. My negative 8 is my b, and my positive 1 is my c. So when I calculate this, I'm going to get negative 8 all squared minus 4 times 7 times 1. So when I calculate this, I get 64 minus 28. And that gives me 36. So that means that the number underneath the radical is going to be root 36. So I'm going to be adding or subtracting 6, which means that I will get 2 different answers. Now, how do you get 1 distinct root? Well, this occurs if the graph has its vertex just touching the x-axis, either pointing down or pointing up. So that means that the value of the discriminant this time is going to be 0. So b squared minus 4ac equals 0. So why does this happen? So if it does equal 0, that means that I don't have anything underneath the radical. So let's take a look at an example. So 1 is a, positive 6 is b, and positive 9 is c. So we get 6 squared minus 4 times 1 times 9, and we can see that we get 36 minus 36, which gives me 0. So that means that when I look at use the quadratic formula, that means that the number underneath the radical is 0. So I'm not going to be adding or subtracting another number. So the only expression, the only part that's left, will be what I have for negative b divided by 2a. So I'm not adding or subtracting anything. I only get one root. And one distinct real root. Real meaning that it's a real number. And as opposed to imaginary. And we can talk about that later on. Now the last possibility is no real roots. So that's when the graph doesn't hit the x-axis. So it misses it completely. And hence there are no solutions because the graph doesn't hit the x-axis. So when does this happen? Well, this means that the value of the discriminant is going to be negative. Okay, so in this case, b squared minus 4ac is less than 0. So taking a look at this example here, again, I have 1 is a, negative 3 is b, positive 6 is c, and I'm going to get negative 3 all squared minus 4 times 1 times 6. And I get 9, so this equals 9 minus 24, which gives me negative 15. So the negative 15 means, let's go back up. So that means that inside this radical, I have a negative number. But we know that we can't square root of negative number, and hence there is no solution. So there are no real roots. So what's actually this is called, when we have a negative inside the radical, these are actually imaginary numbers. And there you have it.